Hello everyone, today we are talking about collision detection. First, we'll talk about what collision detection is. Second, we'll talk about why we need it. And third, we'll go over all the different methods of implementing collision detection. So first, what is collision detection? It's pretty simple. It's often used to simply detect the collision between two shapes, right? These can simply be 2D rectangles. Right now they're not colliding. This can also be a cube, for example. There we go, beautiful. Then another cube. Right, we can also check whether or not these two are colliding. This is obviously very heavily used in games and simulations and whatnot. This is also why we need collision detection for games. Then how do we detect the collision? There are really three main ways to do it. First is to use something fancy like the separating axis theorem. You can also just do a sort of extremely overkill vertex checker, I guess you could say. Then lastly, you could also just compromise in the amount of shapes that you're using and simply have a couple of preset shapes like rectangle and circles, which are very easy to detect. Right, so we'll call this the simple way of doing things. This is also the one that we're going to be using. So first on the list is the separating axis theorem. The separating axis theorem works by simply projecting two shapes onto a sort of surface and then checking whether or not the shapes are overlapping. I've tried implementing this before, it didn't work. But there are a lot of downsides to using the separating axis theorem. It's pretty fast, but the downside is really that you can't check as many shapes, in different sizes. Plus, it's also difficult to implement because it's a difficult algorithm. Then you can also just brute force your collision detection by basically converting any shape into a bunch of vertices. For example, if you have a rectangle, you just get the corners, right? So the four corners. And you save these as vertices in an array of 2D vectors. And then if you have another shape, let's say a square, for example, you can save all of these vertices. For every single pair of vertices in this rectangle, right, you just check the collision between every single pair of the other vertices. And then the moment that one of these two lines are colliding, you know that you have a collision. Now, there are obviously a lot of downsides to this. The first is that you actually have to save all of the vertices of every single shape that you are using, which can be extremely inefficient. And also you have to do a lot of checking, a lot of different line checking, which is pretty performance heavy. Now, the positive thing about this is that you can actually check every single shape imaginable in 2D or 3D, which is obviously very good. But that also has some downsides. Let's say that you want to check the collision between a circle. How do you get all the vertices? Well, you can just choose how many, right? You can sort of give a circle resolution like that. Let's say that you give your circle a resolution of 4, which means you're just going to take 4 different vertices. Now what you're actually doing is just checking a rectangle, so you can scale it up. You can say, well, I'm going to give all of my circles a resolution of 360, right? So that might work and give you a bunch of vertices that you all have to save, right? It's very, very memory heavy. But the moment that you're actually going to be scaling up the circle, so that you have a big circle, this resolution might not be enough to accurately detect the collision. The bigger your circle gets, the higher resolution you need. So in this case, this complete sort of overkill, very performance heavy vertex collision might not be the best way of doing things. Then the last possible way of doing this is to simply compromise, right? Let's say that you want to do this in 2D. There are only a couple of shapes in 2D that really need collision, those being a rectangle, a circle, and a point. And also you could also obviously just implement a line, because why the hell not? Right, for example, detecting the collision between two rectangles is just a bunch of if statements. detecting the collision between a point and a rectangle is also just insanely easy to do. And you don't have to save anything for it. You know, the only things that you need are obviously the properties of your shape, the radius, the 2 points, the width and the height and whatnot. So basically, instead of having a bunch of polygon shapes that you could sort of check with the other two algorithms, you compromise and don't have any of these weird shapes and construct your whole simulation or game from these basic shapes, which is also entirely possible, right? Let's say that you have some sort of object, you know, you're creating a game and you have an object that looks like this. Instead of having one polygon collider, you could just have multiple rectangle colliders, like so. Or replace it and simply have one circle collider. You'll see that in many popular games, this is also how the collision is done, right? Most collisions are just made out of most objects that have collision detection simply consist out of circles and rectangles. That's it. And obviously, because these shapes, right, in 2D and probably also in 3D have just very simple algorithms to determine the collision, this is very easy to implement and also very performance friendly. This way of doing things, you can call this the simple way, is also what we're going to be doing in the next video when we actually code this.